Today we're going to complete our lesson trigonometric relations in its second part. First, we're going to recall the rules we have studied before. The Pythagoras theorem, we have used it a lot in our lesson. It says that in any right triangle, the sum of the squares of the two sides A and B is equal to the square of the hypotenuse. And the trigonometric relations we have studied before are sine theta is equal to the opposite side divided by the hypotenuse. And we have to remember that if this is angle theta, the opposite side will be the side facing it. The hypotenuse will be the side facing the right angle. The adjacent side will be the side which is next to angle theta. Cosine theta is equal to the adjacent side by the hypotenuse, and tangent theta is equal to the opposite side by the adjacent side. Also, we're going to remember that in any acute angle or for any acute angle we have tangent theta is equal to sine theta over cosine theta, which is equal to opposite over adjacent, because if we divide sine theta by cosine theta, we reduce hypotenuse with the hypotenuse, and what remains is opposite over adjacent. And a new rule that we haven't spoke about before is that the square of sine theta, sine squared theta, plus cosine squared theta is always equal to 1, and you can try this rule in different examples. And the last condition that is important is that sine theta is always less than or equal to 1. Cosine theta is always less than or equal to 1 for any acute angle theta. Now we're going to take an example, this table. Find the angle CAB and the length of the missing sides using trigonometric relations of a right triangle that we have recalled now. First, we have to observe this triangle ACB. We can notice that it is right at C, and AB is the hypotenuse with the length C, and AC is a side with the length B, which will be the adjacent side to angle X, and BC is the opposite side with length A. First, we're going to mark the angle CAB, if you can see it here. Okay, and we have to find it in 3 different cases. In the first case, we see that we have the sides A and C are given, and we have to find the angle. A is the opposite side, so the most proper rule that we can use is the sine, because it is opposite over hypotenuse. So if A is the opposite side and C is the hypotenuse, sine x is equal to opposite over hypotenuse, and the answer will be 1/3. Using the calculator, shift plus sine plus 1/3 is equal to 19.47. So CAB is equal to 20 degrees. In the second example, we can see that B and C are given as 4 and 8. B is the adjacent side to angle X, and C is the hypotenuse. So the most proper rule is the cosine X. It is equal to adjacent over hypotenuse, and the answer will be half. You can use the calculator or your memory to remember that cosine x equals half represents the angle 60 degrees. So CAB is equal to 60 degrees. In the third example, we have the sides A and B are given. So A and B are the opposite and the adjacent sides to X. So the most proper rule to use it is that tangent. So tangent x is equal opposite over adjacent, which is equal to 3/4. Use the calculator, shift plus tangent plus 3/4, and you will get 36.86. By rounding it, angle CAB will be approximately 37 degrees. And we have filled our table for the measure of the angle CAB. Now to find the length of the missing sides. How to find the third side? In the first example, we have find the angle CAB as 20 degrees, but it wasn't an accurate answer. We have rounded it to find the answer. So we cannot use the sine, tangent or cosine to find the length of B, because we will not get an accurate answer. It's better to use the Pythagorean theorem. The first example is c squared equals a squared plus b squared. B squared is equal to c squared minus a squared, and the answer will be 72. So b is equal to radical 72, which is 6 radical 2. In the second example, 60 degrees was an accurate answer for our solution. So here we can use two methods to find the solution. Using Pythagorean theorem, c squared is equal to a squared plus b squared. We calculate it and we will get the answer 48. So a equals radical 48, which is 4 radical 3. Or the second method, which is the adjacent side to x and c is the hypotenuse. We calculated x equals 60 degrees. So sine 60 degrees is equal to a over c. And we used this rule because all what is in it is given except for a, which I can calculate it through this rule. Sine 60 degrees, we know it is radical 3 over 2. And if we don't know it, we can use our calculators to find it. It's equal to a over 8. You know that we cross multiply 8 times radical 3 over 2, and we get the answer for radical 3. The third example, also you can use Pythagorean theorem. It's better to get an accurate answer because 37 degrees is a rounded answer. So we use the Pythagorean theorem, c squared equals a squared plus b squared, and we calculate it and we get 25. C is equal to radical 25, which is equal to 5. Before, we have said that trigonometry cannot be used in our life. But today we can know that trigonometry is found in our real life. It is used in engineering, oceanography, satellite systems, sound and light waves. You can see the figures here, how they are using trigonometry, and by using the angle, the heights, and the measure of the sides, and they can calculate a lot of things using trigonometric relations. So sine, cosine, and tangent are not difficult anymore. Hope your point of view towards trigonometry have changed. It's easy if you keep the relations in mind.